The measurement of distance is the most fundamental of all surveying operations, and several different methods are available depending on the accuracy required. However, no matter which method is used, there are only three basic types of distance that can be measured. Two ground points, A and B, lie on a constant slope. The distance along the slope between A and B is known as the slope length or the slant length, and is usually given the symbol L. If vertical planes are added through A and B, then the shortest distance between them lies at right angles to these two planes. This is known as the horizontal distance, and it is usually given the symbol D. If horizontal planes are added through A and B, then the shortest distance between them lies at right angles to these two planes. This is known as the height difference or the vertical distance. It is usually given the symbol delta H. Which distance is required depends on the purpose of the survey work. For example, if you're intending to produce maps of areas, then you will need to measure horizontal distances and height differences to enable plan and height information to be drawn. But if you are trying to fix the positions of the corners of a proposed building, the center line of a road, and so on, then you will need to set out slope lengths and height differences to enable pegs to be located at the correct points. Distances can be measured and set out in one of two ways. Either directly in contact with the ground surface using tapes and chains, or indirectly above the ground surface using optical equipment or electronically operated systems. For convenience, these terms are usually shortened to DDM, ODM, and EDM. Direct distance measurement usually involves laying a tape on the ground surface between the 2 points to be measured. Nowadays, the majority of direct distance measurement is carried out using either synthetic or steel tapes. These come in various lengths: 20 meters, 30 meters, 50 meters, and 100 meters are all available. Synthetic tapes are made of fiberglass, plastic, or a similar material, and are usually graduated every 10 millimeters. If high accuracy is required, steel tapes should always be used, but they must be handled carefully since they will form kinks and can easily break if trodden on or if a vehicle runs over them. Steel tapes are normally graduated every millimeter, and they carry details of their standard temperature and tension. Be careful when taking measurements with them. The 0 point is not always right at the end of the tape. Of the two types, synthetic tapes are lighter and more flexible than steel ones, but they tend to stretch much more when pulled, which makes them less accurate. Some schools and colleges use metal chains instead of tapes because they are much less likely to be broken. Plastic chains are also available. The procedure for measuring a long distance with a tape or chain uses a technique known as ranging. Ranging rods have been set up at A and B at either end of the line to be measured. One of the surveyors, known as the leader, sets off for point B carrying a known number of metal chain arrows or marking arrows. The follower does not have any. Stopping just short of a tape length, the leader holds the ranging rod vertically, and the follower lines it up with the ranging rod at B. The follower holds one end of the tape at point A. It is straightened, pulled tight so that it touches the leader's ranging rod, and the leader pushes a marking arrow into the ground at a complete tape length. The leader then removes the ranging rod and walks further down the line, pulling the tape along. When the follower reaches the marking arrow left by the leader, the whole procedure is repeated to establish a second marking arrow at a second tape length along the line. Once this is done, the leader moves off and the follower picks up the marking arrow before also moving further along the line. The procedure continues until point B is reached, where the last measurement will be less than a complete tape length.
3.55 meters.
The leader and follower now check the number of arrows that have been used.
Okay, that's fine. Great.
The length of the line is given by the number of arrows picked up by the follower, multiplied by the length of the tape, plus the short length measured between the last arrow and point B. As a check, the line should now be measured again, this time starting at B and ending at A. The two measures should agree very closely. For example, over a constant slope of 100 meters, using a 30-meter synthetic tape, the difference between the two values should be within 50 millimeters. And using a 30-meter steel tape, agreement should be better than 10 millimeters. This technique of ranging works well if the ground slopes constantly between the endpoints of the line, but often this is not the case. For example, the ground may change slope several times. In this case, the length along each slope should be measured separately. Sometimes there is a severe drop on the line. In this case, a technique known as stepping can be used. Two ranging rods are located and the tape is held horizontally between them. Since this can be difficult to do very accurately, stepping should only be used for distances up to a maximum of 10 meters, and ideally a third person should be present to check that the tape is horizontal by viewing it from one side some distance away. If stepping is used, it must be remembered that the length obtained is a horizontal distance. In cases where the ground surface is very uneven, or where high accuracy is required, the tape can be suspended between two supports to form a catenary curve. However, the use of tapes in catenary is very unusual nowadays, and, if done, is restricted to steel taping only. The length obtained is the length L along the curve formed by the tape.